NCM Learning Center.
Good morning friends. In this video, we are going to discuss about the uncertainty calculations. Propagation of errors in measurements. In that video, we will discuss the entire concepts in the uncertainty calculations. Propagation of errors in addition, subtraction, multiplications, power and reciprocals. Okay. So, if you watch this video, you can clearly understand the full concepts of uncertainty calculations. So, we can solve any type of questions from the uncertainty calculations. Okay. After that, we will discuss the problems from the previous year standard competitive examinations, GATE, IS and other examinations. Okay. So, now first we will discuss the concepts. Then we will solve the problems. Okay. The rules. We should remember the rules. First rule, for addition, if Q is equal to A plus P, Q is a parameter, A and P also a measurement parameters. If A and B have some uncertainties, then what will be the uncertainties in Q? Del Q is equal to del A plus del B. If you add the uncertainties of A and B, we will get the uncertainties of Q. Okay. So, for example, if R1 resistance have uncertainties plus or minus 1 and R2 have the uncertainties plus or minus 2, then what is the value of uncertainties of RT? If you directly add the uncertainties of R1 and R2, we will get the uncertainties of RT. So, the answers will be 1 plus 2 is equal to 3. Justification. Here R1 is 100 plus or minus 1. So, the R1 value, maximum value of R1 is 101, minimum value of R1 is 99. Okay. For R2, the maximum value of R2 is 150 plus 2, so 152. Minimum value of R2 is 150 minus 2, 148. When the RT will be maximum? When R1 will be maximum and R2 will be maximum, both are maximum, then only the RT will be maximum. So, the RT maximum is equal to R1 maximum plus R2 maximum. So, RT maximum is equal to, here R1 maximum is 100 plus 1, 101, R2 maximum is 150 plus 2, so 152. So, we will get 253. So, RT maximum value is 253. When the RT will be minimum, both R1 and R2 will be minimum, then only the RT will be minimum. So, RT minimum is equal to R1 minimum plus R2 minimum. Here, R1 minimum value is 99. R2 minimum will be 148. So, we will get RT minimum is equal to 247. So, we can write RT is equal to 250 plus or minus 3. RT will be maximum 250 plus 3. RT will be minimum. RT will be minimum when 250 minus 3. So, here answer is 3. If you add this uncertainties of R1 and R2, we will get the uncertainties of RT. So, for addition terms, if we add the uncertainties, we will get the total uncertainties of measurement. This is the rule. Okay. For addition term, we go to add the uncertainties. Next, for subtraction, if Q parameter is equal to A minus B, what will be the uncertainties? For uncertainties, we have to add. If you add the uncertainties, you will get. For example, if height is equal to 5, height means let us take height 5 plus or minus 0.5 meter, small height 1 plus or minus 0.2 meter. Q is the difference, height minus height. Then what is the value of uncertainties in the Q? Based on this formula, the rule, we have to add. So, del Q is equal to del H plus del H. So, we have to add here 0.5 plus 0.2. We will get uncertainties of Q is equal to 0.7. Now, the justification. For the subtraction terms, why we have to add the uncertainties? The justification will give these answers. Here, maximum value of height hypothetical height 5 plus 0.5, so 5.5. Minimum value of hypothetical height 5 minus 0.5, so 4.5. Maximum value of small height 1 plus 0.2, 1.2. Minimum value of small height 1 minus 0.2, 0.8. Okay. When the Q will be maximum? When the Q time will be maximum? When height will be maximum, hypothetical height. When the hypothetical height will be maximum and small height should be minimum, then only the Q will be maximum. Q max equal height max minus height minimum. Then only the Q will get maximum value. So here height maximum is 5.5 and height minimum is 0.8. So we will get 4.7. When Q will be minimum? When capital H will be minimum and small h will be maximum, then only the Q will be minimum. So Q minimum is equal to H minimum minus H max. So substitute here, Q minimum is 4.5, H max 1.2, so you will get 3.3. Here Q is equal to H minus capital H minus small h, so we will get 4. So we may write Q is equal to 4 plus or minus 0.7. Q will be maximum when 4 plus 0.7, 4.7. Q will be minimum when 4 minus 0.7, 3.3. So uncertainties of this term Q is equal to 0.7. So if you add these uncertainties for subtraction term, you will get the uncertainties. So rule 2, for subtraction terms, uncertainties should be added. Okay. For rule 3, for multiplication and divisions, if Q is equal to x, y by z, here x, y, z are the measurements, parameters. Okay. X have some uncertainties and y have some uncertainties, z also have some uncertainties. What is the value of uncertainties of Q? So here the percentage of uncertainties of Q will be addition of uncertainties in percentage x, y, z. Okay. So del Q in percentage is equal to uncertainties of x in percentage plus uncertainties of y in percentage plus uncertainties of z in percentage. Okay. So percentage of uncertainties Q, del Q in percentage is equal to del Q by Q in 100. So this term del x by x in 100 means uncertainties of x in percentage. Del y by y in 100 means uncertainties of y in percentage. Okay. We have to add these uncertainties in percentage for multiplication and divisions. Okay. Justification. We know that Q is equal to x, y by z. When Q will be maximum? Q will be maximum when the numerator term will be maximum and denominator term will be minimum. So when x and y will be maximum and z will be minimum, then only Q will be maximum. So we may write Q max, Q plus del Q. Okay, it's a maximum term. Is equal to x plus del x, y plus del y, z minus del z. Okay. So simplify this equation here, cross multiply and multiply these terms, we will get this del Q, del x, del y, del z. These uncertainties, its values are minimum value. Product the two minimum value, we will get the very minimum value. So we have to approximate this value is equal to 0. Substitute here, we will get these terms. This is very approximately equal. Now simplify this equation. Divide by z on both sides. So we will get this equation. We know that Q is equal to x by z. So this x by z, this Q will be cancelled. Now simplify this equation. We will get del Q by Q approximately equal to del x by x plus del y by y plus del z by z. That means divide by Q on both sides. So we will get this. This is the equation. So here del Q by Q is del Q by Q means uncertainties of Q in percentage. Del x by x means uncertainties of x in percentage. Del y by y means uncertainties of y in percentage. So if you add these uncertainties of percentage, we will get the total uncertainties for the multiplication terms. This is the rule for multiplication. Now the uncertainties rule for the power terms. For example, if q is equal to x power n, what is the value of uncertainties? Here uncertainties in percentage, del q by q is equal to n into del x by x. Same multiplication. For example, if q is equal to x power n means x into x, we could add these uncertainties. So del x by x plus del x by x, we will get 2 into del x by x. This is same that of multiplication. Differentiate q with respect to x, we will get del q by q is equal to n x power n minus 1. So simplify this equation, we will get del q by del x equal to n x power n by x. Okay. Now x power n is equal to q, substitute here, we will get n q by x. So further simplify, we will get del q by q is equal to del x by x, n into del x by x. Okay, this is the justification, mathematical justification. Next, fifth rule for reciprocal term. For example, if 1 by rt is equal to 1 by r1 plus 1 by r2, r1 have some uncertainties, r2 have some uncertainties. What is the value of rt? Del rt, uncertainties of rt. So here uncertainties del rt by rt square is equal to del r1 by r1 square plus del r2 by r2 square. This is the uncertainties. How is there? Now justification. 1 by, we may write 1 by rt is equal to rt minus 1. Here 1 by r1 is equal to r1 minus 1 plus 1 by r2 is equal to r2 minus 1. Here rt have two variables, independent variables, r1 and r2. So if you differentiate rt, it have variable, multiple variables. So if you differentiate this, we will get minus rt power minus 2 n x power n minus 1 into del power rt. Here minus r1 minus 2 del r1 minus r2 minus 1 del r2. Okay, so independent variables. This is a mathematical representation. In measurements, we have to take the del is delta. Delta rt by rt square is equal to delta r1 by r1 square plus delta r2 by r2 square. This is uncertainties for the reciprocal term. Now the concept is over. We are going to discuss the problems. Okay, we will solve two problems. The first question, this question is asked in K 2020 instrumentation exam questions. Two resistors, random resistors having tolerance errors 3% and 4% are connected in series. Then what is the value of effective tolerance? Okay, in this series combination, we know that already the R1 value is given 100 ohm, R2 value is given 100 ohm. In percentage is given. Remember that the percentage is given. So percentage means del R1 by R1 into 100 is given. Del R1 is not given. Del R1 means value, but here percentage is given. So we have to take this del R1 by R1 into 100 is equal to 3. Here 4% is given. So del R2 by R2 into 100 is equal to 4. Okay, it is percentage means del R1 by R1. The value is directly given, means that del R1. But here the value is directly not given. It is given in percentage. Okay. Series connection. So we know that RT is equal to R1 plus R2. If the terms is addition, the uncertainties will be directly added. So del RT is equal to del R1 plus del R2. Our objective is to find the del RT by RT in 100 because effective tolerance in percentage. So first we have to calculate del RT. For the calculation of del RT, we need del R1 and del R2. Okay. So here we know that R1 value. So substitute here del R1 by 100 into 100 is equal to 3. Similarly for del R2 by 100 into 100 is equal to 4 because R1 and R2 value is 100. Now simply this equation we will get del R1 is equal to 3, del R2 is equal to 4. Substitute here, we will get del RT is equal to 3 plus 4 7. Okay, del RT's value is known. RT, what is the value of RT? We got add RT is equal to R1 plus R2, we will get 200. Substitute here, we can get the effective tolerance in percentage. So del RT by RT in 100 is equal to 7 by 200 in 100, we will get 3.5. So effective tolerance is 3.5%. So answer is 3.5%. Next, Second questions from GATE 2022 electrical engineering questions. Here balanced Wheatstone bridge is given, arm resistance is given. We want to find another arm resistance. Answer it is. Okay. So we know this bridge A, B, C, D. Let's take this arm is AB, this arm is BC, this arm CD, this arm DA. Okay, resistance. Under balanced condition of Wheatstone bridge, the opposite product of opposite branch resistance is equal to another branch resistance. Okay, so we'll get RAB into RCD, this opposite resistance, is equal to RDA into RBC. This is a condition of balanced condition of Wheatstone bridge. We know that. Okay, if you don't know, just refer the Wheatstone bridge concepts. We got to find RCD. So RCD is equal to RDA and RBC by RAB. Okay. This product and division terms. Rule 3. The value will be, so RDA is 300, RBC value 100 is given, RAB 1000 value is given. So we will get RCD is 30. So we may eliminate the option C and option D. Answer may be option A and option B. Now we got to find the uncertainties. If we find the uncertainties for this term, we can eliminate this option, we can find one of the best answers. Okay. So this is the multiplication and division terms. If the term have the multiplication and divisions, we know the rule 3 for the uncertainties for this term, the percentage of uncertainties is equal to addition of uncertainties in percentage. So we will get del RCD by RCD into 100 is equal to del RDA by RDA in 100 plus del RBC by RBC in 100 plus del RAB by RAB in 100. So RA in percentage is 0.4, RBC in percentage value is given, so we can directly add RBC in percentage is 0.5 or AB in percentage 2.1, so we will get 3%. Okay, in this option it is not percentage, this is value, so we have to convert this percentage into a value, del RCD value. So here del RCD by RCD into 100 is equal to 3. Okay, here RCD value is 30. Substitute here. Del RCD by 30 into 100 is equal to 3. So we will get del RCD is equal to 0.9. So option B is correct. Now do it yourself. I am going to give 5 questions from the previous year competitive examinations. Just solve these questions. When you solve this question, you can arise many doubts. Okay, if you solve the doubts, you can clearly understand this concept. The questions are, the first questions from GATE 21 instrumentation exam questions, the second questions from GATE 2017 EEE, third questions from GATE 2015 EEE. Just pause this video, solve these questions. If you arise any doubts, kindly post your doubts in the comment section. Okay, the 4 or 5 questions. This is the 4, 5 and 6 questions. This are all the questions from GATE examinations. This is standard exam questions. Okay. If you understand the concepts clearly, definitely you can solve these questions. Okay. The answers for the question. First question is option D is correct, 4%. And second question 4. Third questions option A is correct. Fourth questions 3. And fifth questions B. Option B is correct, and the sixth question is 4. Okay, these are answers. If you have these answers, no problem. If your answer is mismatch, kindly post your answers. Okay. If you have any doubts related to the discussion, post your doubts in our WhatsApp group or in the YouTube comment sections. Okay, definitely you can get the clarification. Okay, good. Thank you. Visit our website www.ncmlearningcenter.com. You can get the video materials for GATE, IAS, ISRO and other competitive examinations. Then PDF materials, PDF book materials prepared for NCM Learning Center. If you use this material, definitely you can get the good marks in the competitive examinations. Then you can get the test series. Join our WhatsApp group, NCM Learning Center WhatsApp group. That link is attached in the description box of the video. Join in our group. If you have any doubts related to the discussion, just post in the WhatsApp group. You will get the solutions. Okay, good. Thank you.
Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.